In this video, we're going to talk about determining whether or not a graph or a function is even, odd, or neither in symmetry. Looking at number one, a graph will be even if the y-axis splits it right down the middle as an axis of symmetry. This is not the same on the left and right of the y-axis. You know, like this, if this were the y-axis, this would be even. So it's not even. Now, a function will be odd if it looks the same when you turn it upside down and the origin is right in the middle, the 0, 0. So if I were to take this and turn it upside down, okay, notice how it still looks the same. Watch, I'm going to snap this back to the way it was. Ready? Bam! Notice it still looks the same, so that makes this odd. Now, when we're talking about looking at a function, we're given an equation, we can tell at a glance whether it is even, odd, or neither. If all the exponents are even, then it's even. If all the exponents are odd, then it's odd. If there's a mixture, then it's neither. In this case, I have a 3 and a 5, and this x is like an invisible 1. So far, everything's looking odd. But wait, the constant 3. This is like having 3x to the 0 power. So this is actually an exponent of 0, and 0 is an even number. So we have 3 odd numbers and an even. So that's a mixture, so this is actually neither. All right, so watch out for that. So, oh, I almost scrolled on to the next problem. Silly me. Now, so at a glance, we know whether it's even, odd, or neither. But we need to determine algebraically, all right, like a proof. And so here's how you prove and algebraically that something is even, odd, or neither. So the first thing you want to do is create the opposite function called negative f of x. And that's where you just do the opposite of every term. So that would be negative x to the 3rd power, positive 2x to the 5th power, minus x minus 3. All right, so I've got that. Next, I want to do f of negative x and see what I get. So if I have negative x to the 3rd power minus 2 times negative x to the 5th power plus negative x plus 3. Let's just simplify this down and see what we get. If you have an odd power, the negative is going to stay. So even without parentheses, this will be negative x to the 3rd power. This negative is also going to stay around because I have an odd power. That means I have a negative times a negative, which is a positive. So I will have positive 2x to the 5th power. This negative is not going anywhere, but instead of having plus negative, we'll just write minus x. And then, of course, we'll bring down the plus 3. So you're supposed to take your f of negative x and see if it matches either the original function or the opposite function. Okay, it looks pretty similar to the opposite function until you get to the last term. Here we have a positive 3, but that was a negative 3. So they're not quite the same. So f of negative x does not equal either one of these. So that's why it's neither. So in a summary statement, which is mandatory, you would write since f of negative x does not equal f of x or negative f of x, it is neither. All right, so that's how you prove algebraically. Hey, let's look at another example as we do number 3. All right, I'll probably do a little faster this time. So first you do the negative function by doing negative f of x, and so that's negative 2x to the fourth power plus 5x squared minus 7. Hey, wait, I just remembered. Before we do anything else, at a glance, let's just say whether it's even, odd, or neither. So looking at all the exponents, I have even, and here I have 7x to the 0 power. That is even as well. So everything is even, so I know this is going to be even at a glance. So now let's continue on with the proof. So now we do f of negative x. So that's 2 times negative x to the fourth power minus 5 times negative x squared plus 7. Now let's simplify that down. When you have an even power, these negatives are going to disappear. So without parentheses, this will become 2x to the fourth power. This negative is gone, so I just have 5x squared and then plus 7. So I look at this and I compare it to the original function, and I notice that they match. Okay, these two are the same. So that's how I know it's even. So I'm going to say in my summary statement, since f of negative x equals f of x, it is even. And that's it for number 3, and that's the end of this video. See you on the next video.